In this problem, we're going to identify all the vertical asymptotes for r of x is equal to x over x squared plus 5x plus 6. Before I find the asymptotes, I want to figure out what the domain is. So to do that, the first thing I want to do is factor the denominator. So x over x plus 2 times x plus 3. And if we're going to find the domain, I know the denominator as a whole cannot be equal to 0. So I'm going to say x plus 2 times x plus 3 cannot be equal to 0. And I'm going to set both parts not equal to 0. So x plus 2 cannot equal 0. X plus 3 cannot equal 0. So x cannot be equal to negative 2 because that would make our denominator equal to 0, and we can't divide by 0. X cannot be equal to negative 3 for the same reason. If you put a negative 3 in right here, negative 3 plus 3 is 0. 0 times x plus 2 would also be 0. So the domain is all real numbers except our excluded values of negative 2 and negative 3. Now the asymptotes, the vertical asymptotes, relate to the domain. So let's mark this domain. Okay, the vertical asymptotes go off of any factors of the denominator that are not also factors of the numerator. In this case, x plus 2 and x plus 3, neither are factors of the numerator. We'll talk about that again in a second. So, since we have excluded values at negative 2 and negative 3, our asymptotes are at x equals negative 2 and x equals negative 3. Those are our two asymptotes. Now, a couple seconds ago I said if it's a factor, like if x plus 2 is a factor of the denominator and the numerator, that does not make an asymptote. So let's take an example of where that's the case. So let's say f of x is equal to x times x plus 2 over x plus 2 times x plus 3. Now, if we were to find the domain like we did in the last problem, we would use both factors from the bottom. We would say x plus 2 times x plus 3 cannot be equal to 0. So x is equal to negative 2, x is equal to negative 3, all real numbers except for these two. And in the previous problem, we just took our domain, our excluded values from our domain, and we found x equals negative 2 and x equals negative 3. That only works if the factor x plus 2 and the factor x plus 3 are not also factors of the numerator. So if you look down here at this problem, the f of x, x plus 2 is a factor of the top and the bottom. So they would essentially cancel out, and we'd be left with x plus 3. While negative 2 would still make this, would still allow this to be equal to 0 and would still be an excluded value of the domain, it cannot also be an asymptote. So our only asymptote in this particular problem is x equals negative 3.